Bonjour et bienvenue à tous. Bienvenue à cette autre activité organisée par la communauté de pratique en sciences ouvertes de la Direction générale Sciences et technologies. Mon nom est Martin Jean et au nom du comité organisateur de la communauté de pratique, je suis très heureux de vous présenter le Dr. Julia Stewart Lowndes. Dr. Lowndes est la directrice fondatrice d'OpenScapes. Elle se fait la championne d'une science plus douce et meilleure en moins de temps grâce à la science des données ouvertes et au travail d'équipe. En tant que spécialiste des données marines, boursière Mozilla 2019 et Senior Fellow du National Center of Ecological Analysis and Synthesis de l'Université de la Californie à Santa Barbara, elle a conçu et dirigé pendant plus de 7 ans des programmes visant à doter les équipes scientifiques, dont la NASA et NOAA, de compétences et de comportements pour une recherche reproductible en donnant aux chercheurs les moyens d'utiliser les outils et les communautés ouvertes existantes. Elle a créé des communautés de pratique depuis 2013 avec l'Ocean Health Index, après avoir obtenu son doctorat à l'Université de Stanford en étudiant les facteurs et les impacts du calmar de Humboldt dans un climat changeant. Elle est institutrice Carpentries, créatrice principale de la formation en sciences des données ouvertes de l'Ocean Health Index et cofondatrice de Eco Data Science et du chapitre Our Ladies de Santa Barbara. La conférence du Dr. Stewart Lowndes s'intitule Open Practices for Better Science in Less Time. La présentation se fera en anglais. Vous pouvez poser vos questions dans la langue officielle de votre choix. Hello everybody and welcome to another activity organized by the Open Science Community of Practice of the Science and Technology branch. My name is Martin Jean and on behalf of the organizing committee of the Community of Practice, I am very pleased to introduce Dr. Julia Stewart Lowndes. Dr. Lowndes is the founding director of OpenScapes. She champions kinder, better science in less time through open data science and teamwork. As a marine data scientist, 2019 Mozilla Fellow and Senior Fellow of the National Center of Ecological Analysis and Synthesis from the University of California at Santa Barbara, she has designed and led programs for more than 7 years to help science teams, including NASA and NOAA, with skill sets and mindsets for reproducible research, empowering researchers with existing open tools and communities. She has been building communities of practice since 2013 with the Ocean Health Index after earning her PhD at Stanford University, studying drivers and impacts of Humboldt squid in a changing climate. She is a Carpentries instructor, lead creator of the Open Health Index, Open Data Science Training, and co-founder of the Eco Data Science and Our Ladies at Santa Barbara. Dr. Stewart Lowndes' lectures is entitled Open Practices for Better Science in Less Time. The presentation will be in English. You will be able to ask your question in the official language of your choice. It's yours, Julia.
Wonderful. Hello, everybody. Thank you so much for those wonderful introductions. Merci beaucoup. Are you able to see my screen and hear me?
Yes.
Wonderful. Thank you. Well, yes, I'm so excited to be here and to share a little bit about open practices for better science in less time. And I'm really looking forward to the discussion as well, because I know that you've got a lot of really exciting things going on within your community of practice and beyond. So thank you so much for this invitation, and I'm really excited to be here. So the way I have been thinking about open practices and better science in less time recently is that the problem that we're trying to tackle is that we're often approaching data analysis as an individual problem and an individual burden. And we see this in the way that we maybe don't teach data analysis in our formal education, and how people kind of have to learn as they go without a lot of support. So this is a problem because it's a slow process. It's really brittle because people people aren't able to share what they know very easily, and so teams teams aren't able to have the resilience that they might have otherwise. It's also really demoralizing, and it really perpetuates inequities. The idea of you being able to do science based on what you like already have had in your past and what you've learned before versus being able to do the best science you can, learning together. So I think a contributing solution here is really to reframe data analysis as a collaborative, open practice, and to really build our science and our analyses around the idea of how to make them most efficient, how to make these analyses and ideas more resilient within teams and lasting, and also to really think about how data science and data analysis can be an empowering activity and can be an inclusive activity that everybody can participate in, so that we can really think about science in a whole new way. So I like to talk about this with Star Wars analogies, and I'm very lucky to be able to work with Allison Horst, who is an incredible artist and has made all the artwork in this talk. So if we think about Star Wars, we've all felt like this before when it comes to data analysis. We've all had a challenge in front of us that we can't solve with the skill sets we have. And it can be really demoralizing and lonely. And if you can imagine that Luke tried to solve this challenge with whatever tools he already had with him, like whatever ropes or pulleys might have been in this X-Wing, the result would not have been very pretty or something that he was very proud of. It wouldn't have been reproducible or something that he could have learned from and built from. And it probably wouldn't have gotten him to where he needed to be on time. And I think all of those things are really true when we think about environmental science too, especially when we're thinking about climate change and really needing to be there on time. But luckily, Luke didn't have to solve this problem alone, or with what he already had on hand, because Yoda came along, and Yoda used the Force to solve Luke's problem in a way that Luke never imagined was possible. And this is going to change Luke's whole mindset and approach, because he's going to be able to see what's possible, learn what's possible, and he's going to be able to solve the challenge in front of him. But also it's going to broaden his whole imagination and his whole scope for what he will do next. So the scale and the size of the challenges that he can tackle next. And so I think of the Force as being really open practices and open data science and all of the tools that we'll talk about more today. But importantly here, Luke did not do this alone. He did not go on to tackle these bigger challenges. He had a whole community. And this community that he worked with was super powerful because it was a very diverse community of different backgrounds, different expertise, different skill sets. Not everybody had the same skill sets. Not everybody was a Jedi, but everybody was contributing to this bigger effort in really critical ways. So I really think of open data science as the force that enables scientists to do better science in less time. And for me, R is a big part of this, and you'll see that. But there's also really important practices with Python and other tools as well. So even though I'm focusing on R, that's just a piece of open science. But really R empowers us and to really get our data out of that swamp and to build off of our confidence and our experiences to broaden the scope of the science challenges that we can tackle. So my talk is really going to be framed around two ideas, that the software and the practices really go hand in hand. So I think about open data science as the tooling and the people that are enabling reproducible, transparent, and inclusive practices for data analysis. And the tools like R and the practices that you use around R, like, for example, using the tidyverse or using R with GitHub, are really, really powerful on their own. But what makes them game-changing is that you can use those tools with other people, with your future self, with your teams, with your communities. And those shared practices have with those tools lets you do things that are really beyond beyond our imagination. So let me give an example talking about the Ocean Health Index. This is a project based at the National Center for Ecological Analysis and Synthesis, where I am based as well. And the Ocean Health Index is it's an assessment framework to quantify the benefits and the impacts of oceans at different spatial scales. So I've worked on the Ocean Health Index since 2013, and there's a lot to say about the science and the use cases and just the exciting work going on the management front as well. But I'm not gonna get into that. What's relevant here today is that we combine and model lots of data. We repeat our analyses every year, and we do it as a team. But because we were a team of marine ecologists, we all came from varying levels of self-taught analytical experience. And we found out the hard way that our default approaches to data analysis were not reproducible even by ourselves. So getting through this process involved quite a reckoning, but when we got through it, we knew we had a story to tell. And we shared this story in this publication, Our Path to Better Science in Less Time Using Open Data Science Tools. And I think what made this story unique was that we shared our struggles that we had encountered when we couldn't reproduce our own work. And then we shared the transition to how these open practices reframed the way we thought about science and the way we did our science. So this is a figure from the paper, and it shows that as we repeated our analyses each year, it shows that as we repeated our analyses each year, we found that it was easier to, our analyses were easier to reproduce on the y-axis there, and that it was easier to collaborate with ourselves each year on the x-axis there. And then we also found that it took less time to complete our analyses each year, and that's the size of the circles. And so the way we were able to do this is because we started introducing open data science tools and practices little by little each year so that we can improve the whole way we worked. And so at first we focused on the repeatability of it. How could we make it easier to just do the assessment the second time with updated data? And then we started focusing more on collaboration and then ease of use, and then also getting into communication efficiency and finally training. And that's a really exciting part of this as well, that we can talk about later. But I wanted to highlight the motivation behind doing all of this too, because we were really motivated by being more reproducible and efficient, specifically around data wrangling. And that's something that we'll talk about more throughout this talk, but this is kind of this unseen part of data analysis that is not about the scientific models that you'll be using to answer the questions you want to ask, but it's in the preparation of your data. This can be a really messy, long, involved process. And it was something that we had not thought about in terms of reproducibility before embarking on this journey. Another thing is that we found new frontiers for collaboration and communication through using open data science tools. And that really opened our mind to who was a collaborator and who we could learn from and create with, and also how we could communicate our science and think outside of the sort of formal ways of publication only. And then finally, and this speaks to your community too, is just we're just amazed continually by the communities of practice around open science. We really, back in 2013, when we were starting this journey, it was really the budding online communities that really helped us see what was possible and encourage us to do more. So what this looks like, a little bit more in depth for our team, is that reproducibility was really the keystone of what we were doing. So this meant that we all decided that we were going to code all of our analyses and data preparation. We were going to do that in R. We were going to start using the tidyverse as as an idiom so that we could more easily collaborate on code together. And we were going to use version control. So these are, not only using tools, but actually creating new habits within each of ourselves independently. And then from those independent habits, we also created like more of a shared culture with those habits, where we used R and GitHub to then collaborate and communicate. And for this, we were able to do this in the cloud and online. So by using GitHub and having shared practices, how we coded in R, we were able to then have shared record keeping, more easily share files, and then use those same tools, our Studio and GitHub, to then communicate more broadly, not only to share data and code, but also share our methods and teach in different ways that we had never thought of before. So our Markdown, just to give a little sense of some of the tools that we're using, our Markdown has been just absolutely game-changing for the way we're doing science. And what our Markdown is, and Jupyter Notebooks is a similar idea if you're a Python, if you're more Python oriented. Our Markdown lets you not only reproduce your code by having it in a single document that you can rerun anytime and make any changes to, so you're able to more easily reproduce your own work as you create it, and others can as well. But because our Markdown combines code with written language, in this case English, you're able to then, we call it knitting it into different document formats. So you're able to create essentially a report in Word, or as a PDF, or as a web page. And this is really exciting to be able to, for me, it's, I wrote here, imagine never copy pasting a graph into your Word document again. And that is a huge, that was a huge thing that got me excited, because the amount of bookkeeping and copying and pasting and little steps that you have to do in order to create a report, not using this method, is the differences and the amount of time that gives you to focus on your science rather than on that bookkeeping is really exciting. And with our Markdown, it really helped us reimagine communication, because one of the formats that you can knit those documents into is into web pages. And so this let us create a website for the Ocean Health Index that had all of our data and underlying analyses underlying them. And when we would make an update when we would release a new assessment, because we reanalyzed with updated data, we were able to, with a click of the button, push this all onto the website and have that there for anyone to learn from. We're also able to create not just the single web pages, but also books. And these slides are also created with our Markdown. So there's a lot of really interesting ways that you're able to share your science and share, to really communicate around your science, that are in this whole new way of thinking. Another really powerful thing for us has been Shiny. And I was just talking to Martin about this beforehand, that you're working in Shiny, or will be soon. This has been really exciting for us through the Ocean Health Index, because creating a dashboard, like an interactive dashboard using R and the idea of our Markdown, has let us it's not about only communicating your science at the end of a project, but also for stakeholder engagement and to share progress along the way and have meetings where you're really helping folks understand the underlying data and assumptions and models and figure out what to prioritize moving forward. So this has been a big part of the Northeast assessment of the Ocean Health Index that Jamie Afflerbach Montgomery led. And I just wanted to show some examples too that aren't from the Ocean Health Index at all, but just of exciting other activities. And these are just two of many, many. But using spatial analysis in R to track animal movement in the North Pacific here. And this is all using R. And you can actually, this is just a screenshot on the left there, but that's a GIF you can create in R so that you can actually look at the animated movement of those animals, which is really cool. And then on the right here, this is a water quality report card for Tampa Bay in Florida in the US. And this document, screenshot on the right, is the style with this red, yellow, green that has been used by this group for decades, but now it's created in R Markdown. So that report and that styling is all has underlying R code, so that as the analyses are updated each year, the new report can be generated with this style easily. So I think, that's just some examples of tools and uses, but I think what's really important is like the power of the people and teams and what you can create together. So I mentioned these online communities. These are the communities that really inspired us starting in 2013 and continue to today, although there's many more today. But these groups were creating code and creating tutorials and really interested in not only providing tools, but like helping new users like us learn about how to use them and provide feedback so that they could be easier to use for more people. And this continues to go on today. There's teaching communities through the Carpentries, there's meetup sessions through Our Ladies, and there's a lot of conversations on Twitter where we all share news and learnings together. So just two examples of that are learning GAMs in R. There's a incredible tutorial available online, and this Our Ladies group was going through this tutorial and sharing little lessons that they were learning as they did. And then also using doing spatial analysis in R and having tutorials and sharing with others about how not only how to teach a group in front of you, but how other people can use this tutorial in their own meetups as well. So what I love about this is, it's the tools and the people, and it's really creating these shared practices and shared habits and shared culture. And I love this quote by Jenny Bryan and Jim Hester, who say, "It's like agreeing that we'll all drive on the left or the right. A hallmark of civilization is following conventions that constrain your behavior a little bit in the name of public safety." And I think, this is a big part of collaborating around data analysis and of thinking openly. Is it means you need to, you might need to give up some of your own little habits that you've created throughout the years, but to really think about what would make it easier to not only work with other people around you, but also to onboard new folks to your team and to your work. And so some of these mindsets that have really transformed the way I think about this is this graphic from Wickham and Grolman, R for Data Science. And this data science mindset just absolutely changed my whole world, this more than anything else, maybe. So if we look at this graphic, this is the idea that no matter what your study system, no matter what your science question, you will go through this process with data analysis. It means you're going to have to somehow get your data imported into an analytical place that you'll be able to work with it. And if you tidy that data, which we'll talk about in a moment, then you get into the science part in gray, that understand. That's where you're modeling, that's where you're visualizing, that's where you're transforming the data and really understanding the questions you're asking. And then you're able to finally communicate at the end. And I think why this changed my whole perspective so much was this sort of tidying and data wrangling part. Because if you're able to focus on that sort of data processing or data preparation or data wrangling part as a precursor to your analytical questions, you'll be able to really, it'll be a lot more easy to isolate where your science questions are and how to go forward from there. But I think for me, maybe let me step back. I feel like I'm getting ahead of myself. An example during my PhD was when I was when I was first dealing with my data for the Humboldt squid study, I wanted to change the date format into an ISO code based rather than the MATLAB format that I was working in. And I couldn't separate that date formatting question from my research question. And so I didn't know where to look to ask that question. And so I was looking in the cephalopod ecology literature for a question that was a data science question. So I was approaching this problem like it was a research question and a science question and an ecology question, but it was actually a problem that many people had solved before. And if I had known to look somewhere else, I would have been able to get there sooner. So I think it's really important to distinguish this tidying and transformation as separate from your research questions. And I think what's really cool is that along with that data science mindset, there are tools available every step of the way. So this is an example of some of the R packages that exist to help you import your data and just to have that expectation that someone has done this before, whether you're using a CSV file or an Excel file, or you're scraping from a PDF, or you're pulling from a URL, or you're accessing a database. That is not a squid ecology question. That is a data science question. And there are tools for it that are available that you can leverage. And so I've been thinking about this as, working with tidy data lets you use existing tools in really familiar ways. So rather than handcrafting one-time approaches and feeling really lonely and frustrated, like on the right, you're able to, if you format your data in this tidy format, you're able to then use existing tools more easily. And this lets you collaborate more easily, whether this is with yourself next month or next year, or whether it's other folks around you now or other people that might be joining your group in the future. If you share this mindset, the collaboration is a lot easier. And it lets you more easily reproduce and reuse your code and your analyses. Because if everything is expecting the same inputs and outputs, then you're able to iterate a lot more easily. Additionally, an open mindset, along with the data science mindset, is this is several definitions of open science: is the transparency at all stages of the research process, coupled with free and open access to data, code, and papers. And then additionally, there's an idea of how open science needs collaboration and empowerment and inclusivity and accountability. And the sense of trust and being safe to be vulnerable is also a big part of open science and an open mindset. And as I've been saying here, I'm really interested too in how the technology, how these open tools really enables the social infrastructure too, so that those tools and making it easier to collaborate and to think together can also promote inclusivity and help us towards kinder science. So going back to the Ocean Health Index and the tools and the tooling and people idea, on the left here, I've been talking about the tools we've been using, the R, GitHub, we also use Google Docs and Twitter. But really important too is on the right, on the people side. And really critical to our success was really supportive leadership within our Ocean Health Index team, both vertically from our PI and horizontally within our team. And we all trusted each other. We were kind to another, and we were all willing to learn with each other and from each other. And so from there, we were able to then create these whole shared workflows using those tools. And it was this iterative cycling between seeing a tool and then bringing it into our practice. But it was really with this trust and idea of co-creating together is really important. So what I've been really interested in is how, this is this sort of cycle that I think is really exciting, where, as there's new tools available, if you work as a team, you'll be more easily able to adapt with them. And if you trust each other and work well together, you're more likely able to take on new tools and practices. So it's like this exciting cycle. And what do you do if you're not in it already, or if you're interested in bringing your teams to these new open ways of working? So this is where I created Openscapes as one way to help onboard teams to this world, and I think it's an exciting thing that I know you are all going to be working on as well. So I'll talk about this just for a few moments here. So Openscapes is a program at UC Santa Barbara at NC's where I'm based, and really our flagship program is the Openscapes Champions Program. And this is an open data science mentorship program for teams. And the idea is to empower teams around these ideas of efficiency and resilience and inclusivity, and to onboard them to not only skill sets, but mindsets around this, and focusing on creating leaders and community within teams and connecting across teams. So part of the idea is that the curriculum is based on our experiences with the Ocean Health Index. So how to take the lessons we learned over 4 years and help other teams get onboarded to those practices more quickly. It's a remote course that is cohort based. So, and it's based off of the Mozilla Open Leaders program, which has been incredibly formative in my experience as well. And so it's several hours a month, three-ish hours a month for 2 to 4 months as a cohort of teams. And like Martin mentioned as well, we've had environmental scientists from academia and from NOAA and government so far. And some of the things that these teams that have gone through this program have done is they really start off by thinking about shared practices and values for their teams. So these are 2 examples from academic research labs, where the Pinsky lab on the left there started off by thinking about what their shared methods and shared scripts were, but also how they work. And this how we work repository, they're using GitHub, they're using these shared tools as a way to not only co-create, but also make visible their values. And so how we work is the idea of making it easier to onboard new grad students to their lab, new undergraduates, summer interns and whatnot. And then I think on the right here, Holly Freilich has also used this as a way to explore how to be a better anti-racist in science, and is using this as a way to really put her values forward that way. Additionally, all these groups are prioritizing learning together and teaching each other. So on the left here, the Wood Lab is having meetups within their regular academic lab group sessions where they focus on learning coding together and creating shared practices. So they're calling these their Bayside chats. And then the Fay Lab was also doing this in person as well, and then obviously switched to remote during the pandemic. And they made a point especially that having participated in this remote collaborative program helped that transition more to be a little bit easier. But I think, those are just a few examples, and I am happy to talk about more, and especially through time. But I think there are just so many wins that people shared as they tried these new habits, new tools, and tried to connect them and practice them together in science. And I think this quote at the end was really just made my heart so happy, where Malin Pinsky said, this isn't just about coding and GitHub, this is about changing the way we do science. So we shared some of these lessons in a publication called Supercharge Your Research, and it's a 10-week plan to onboard your teams to open data science. And I know that this is what some of you will be doing together with Martin and others. So I'm really excited to hear about your experiences and to help amplify and connect with you as much as you're able as you go through. But it's really about steps to take to really normalize talking about data so that you can identify and address shared needs around data analysis, and then start thinking ahead for future you and future us and kind of reimagining your collaborators. So I just want to end with a quote that also really inspires me. That's, if you want to learn to write, you read a lot. And if you want to play music, you listen a lot. And it's hard to do this with data analysis. So this is a quote from the Not So Standard Deviation podcast at the RStudio conference by Hilary Parker and Roger Pang. And they were saying this in the context of why it's so important to share our tools and our practices and our challenges and our solutions around data analysis, and just have more open practices with each other so that we can all learn and do better together. So thank you so much for having me, and welcome to Open Data Science, and and welcome to others if you've been here already. But I'm really excited for what you're doing, and I'm excited to stay in touch. So thanks.
Thank you very much, Dr. Lowndes. Now, if anyone has question, you are invited to either raise your hand. We can give you the mic so you can ask your question, or you can also write your question in the chat. There is a conversation with the presentation, and either me, Dominique, or Martin can ask the question for you. You can ask the question in either French or English. We will take we will do the translation. So yeah, the floor is all yours for any questions. Go ahead, Monica.
Hi, Julie. Thanks again for such a great presentation. My question is, do you have, at the end you talked about that really great quote that is showing how helpful that these programs and open practices are to the functioning of communities and of science. Do you have a place where you keep all of that information so that we can take that to, senior leadership here at Environment and Climate Change Canada and show them that, we need to have tools and policies that allow us to succeed in using these tools?
That is a great question. And I guess the short answer is I don't have a place where that is all sort of presented for that audience, but we should. So I'll add that to the list. Have you had any experience in talking to policy folks and trying to make this argument? That's an area I haven't been as close to.
Yeah, we definitely can have a discussion about that. I think that there are certain things that I think the open science space is moving very quickly, and it likes to innovate and push boundaries. And that's not necessarily a culture that you'll see in government. And so to keep up with some of this innovation, it's difficult to do if there's no policies that explicitly permit, for example, even the use of GitHub. So it's it's a case you'll have, it's not that the answer is no, is that you just have to make the case for why this is useful, and to sort of think about the different considerations and potential drawbacks to implementing any one of these tools. There's also the issue that data needs to stay usually in government hands if it's government data. Doesn't mean it can't be open, but it should be on servers that are in Canada. So yeah, I think it just, something that if we were to make a case for hey, let us use GitHub, it would be great to have examples that we can draw from showing that it's been successfully used in, a policy brief that we send up to senior management.
No, that's really great. One of the things I've been trying to do is help share case studies or examples, sort of the bright spots of using GitHub in government that can, through a storytelling lens that can provide examples and maybe muster interest that way. So that water quality assessment report I shared, we cross-posted a blog about that and are just trying to share that story more broadly. And I think that's a big role I see us playing. But I'd also love to figure out how, like, whether that's effective and what could contribute to the types of the other efforts going on. I think like GitHub as an example can be pretty it can be not only intangible but also just like very it's hard to see a use case for it necessarily exactly. So I think just trying to share some of the stories can help too, if that makes any sense.
Yeah, no, definitely.
Yeah.
Thanks.
Yeah, thank you.
Maybe I can ask a question. Julia, how would you say, what would you say to encourage an individual who has never coded before and is afraid to jump into that adventure?
Yeah, I would say that they're not alone, and whether that is with me, if we're going to sit down and look at some code together, or if they can find a friend to code together. And I think I mentioned online communities, and that has made that feeling of alone or loneliness around learning how to code. I think that's helped a lot with that. For example, there's a Slack community that exists that reads the R for Data Science book together, so that wherever you are in the world, if you're reading that book to learn about R, there are people all around the world who are like in a Slack channel with you, reading chapter 1 that week with you. And so having this idea that, we're not alone, it's not too late for you to learn how to code, it's this really exciting, empowering activity, I think is a big part of it, like having it be a welcoming experience.
Okay, thanks.
I might just jump in. I was wondering, there is a lot of talk about all the data science around open data, and that's one of the focus that we have here in Environment and Climate Change Canada, that and publication. But I feel like there is so many other topics or group of knowledge that can be drawn from open science, and I was wondering if you have like a favorite that is not the data science, or things that you think it's the most important to like integrate in our daily works, but that is not data.
Mm-hmm. That's a really good question. I think I don't know if this is quite the answer you're looking for, but I think blogging and Twitter are a huge part of open science and open practices that are not strictly data, but it's just as a place to learn what's going on and to connect to other people. So, I schedule time in my day to look at Twitter, and it's a time for me to learn, which is it's always hard to carve time of your day to learning. Like that's, for me, that's always gets pushed to the bottom with all the things I need to do. But seeing what people are talking about on Twitter around open practices has been really transformative for me. So I joined Twitter to learn R, but it's through Twitter that I've learned so much more about diversity, equity, and inclusion, and just heard the conversations that are going on around open science and otherwise. Twitter is how I found Mozilla, who are not only focused on data or on open science, but they're focused on open as a broader movement and thinking about open health and open government, and they're thinking privacy and, security, misinformation. They're thinking about open in a much broader way than I had experienced open. So I think through, Twitter has opened doors to those conversations and to new ways of thinking about open. And that's been really, really transformative for me. And then the blogs kind of come in because people often tweet about blogs that they've written or that they've read. And so that's a way to get, more in depth into some of these ideas that are sort of brought to the surface through Twitter.
Thank you very much. That was actually the answer I was looking for. So
Great.
Great. It's not a question, but people want to see you, Julia. So would you mind stopping your screen sharing?
Yes. Am I back?
Not yet.
There I am. Sorry, I didn't realize that.
Yeah, good.
Defaulted, turned off. Hello.
It's Dominic here. I was wondering if you could talk also about Twitter or a blog that help you with your science, like finding about squid or I don't know, and how people being open and sharing about their science was a benefit for you.
Mm-hmm. Yes, I would love to talk about that. And actually, I will screen share again if that's okay, because I have a few examples that I could walk through. So let's see. This is this is again about Twitter and finding those people and having it help my science. So this tweet in particular just changed, I think really encapsulates your question. So I don't know this person, but this plot caught my eye when it came up in my Twitter feed. So I saw this time series of something, it turns out to be precipitation. But what I saw when I looked at this was, what a cool visualization. I want to do this with my data. This is something I want to do with my data where, some, years are transparent and then 1 year is pulled out as the one you want to show, right? So I was like, this is what I want to do with my, with my Ocean Health Index analysis. And so I also then saw from this tweet that the person shares their code because I see that GitHub link. And then additionally, this is like the social side of it too, is that he's tagging Scotty, who I know is part of this R Open Sci community. And so I know that this R package, in this case, it's called R NOAA, is a package that, is kind of vetted in a way because it's gone through code review through this community that really puts open and inclusion first. And so I learned all of that just from this tweet. And what I think was really like an additional part of the story is that I shared this story in one of the first OpenScapes cohorts. And one of the participants said, she works with NOAA data all the time. She'd never known that there was this R package. And so she amplifies that she's just learned about this. And actually, then the developer, Scotty, is able to say, oh, that's really great. I'm glad you found it and like it. So, it's just this amplifying series of cascading events that started with this tweet. Yeah. So that's,
Good.
I'll stop there.
Right. Thank you.
Of course.
Any other questions? Autre question?
I have a question, but I'm not sure if you can answer it, but you can let me know what your thoughts are.
Okay.
Well, first of all, your enthusiasm. I mean, even though we couldn't see your face, we could definitely feel it. So that's great. I wonder where to start in order to, it's one thing to get a few people excited, but how do we make sure it spreads? I mean, eventually it will. It's obvious. And it brought me back to remember when first GIS tools came out? Only a few specialized people were keen and knew how to use them, and so we would have a specialist in the team, and they would help. And it was the same thing when we first had stats tool. It was the same thing. And now everybody that comes out of school almost know how to do something with stats. I mean, they still need an expert for some consultation, but generally people know how to do it. And the same thing with GIS. So I was wondering, do you see the same path for programming? Because it's not every scientist who, I mean, they all want the benefits from it, but they're not all keen on learning it and doing it. And the initial reaction that I tend to hear from people who are now out of school and they haven't seen it in their school is like, oh my God. And they have this, it's almost a visceral reaction. They want the benefits, but they're so freaked out by what it means. And so I wondered if you had any thoughts about that and how to address it or lower the obstacle. I don't know. But, you know, until everybody from the older generation is out of the workforce, you will still have those people that we have to support and provide help.
I'm really glad you brought this up. I feel like this could be like a hours and hours long conversation. I think maybe the place I'd start in thinking about this is I think the focus on teams is really important here. And, you know, that idea, that picture of all the Star Wars people with their hands in, like, I see that as a really important way to go forward with programming and coding, because not everybody needs to code. Like, absolutely, like that's not, I think, something that drives me. I'm not everybody needs to code in R, but if everybody can see what's possible and feel included in that vision, then like we can all interoperate more easily. So, and a tangible example is with our Ocean Health Index team, our PI does not code. But when we got excited about wanting to learn how to code, he supported us. You know, he let that be part of our job to learn how to code and to put in the time up front to figure out like where to store our data and how to name our files and how to all access. You know, he let us put in that time so that in each year it would take less time going forward. But he has a GitHub account, and just so that our conversations that we have through GitHub show up in his email box. That is his level of engagement with GitHub and R, but he's a huge part of all of the conversations that we have around code, and we share our plots and whatever, and those tools allow him to participate in the exact level of participation he needs, right? He doesn't need to learn how to use R and GitHub, but if we can all use them together towards something shared, it's really powerful. Okay. Yeah, so that's one. I mean, I feel like that's something that we can do in our own ways now, you know, and that's really trying to replicate that is really what OpenScapes is trying to do on those like team level steps. But I think additionally, you know, it's there's a lot more to happen with, you know, policy and incentives and rewarding people for working openly and more reproducibly. Yeah, so there's a lot to do, but I'm hopeful.
Yeah, as I said, your enthusiasm is definitely there.
Yeah. I think that's a big part of it, is that it's awesome, right? I think it makes people feel really powerful, and that's something that we need in science. Like, I think there's a lot of times where it can be really lonely and demotivating, and, you know, I frankly think we lose a lot of really great people because it doesn't feel as it should. So, yeah.
If I may add something,
Yeah,
know, Alexandra, older generation can also learn new things. Okay.
Yes.
And one of the one of the priority that we have in our community of practice is to help newcomers to slowly get used to coding, not necessarily to produce or create thousands of lines of code, but just to use them and have a basic understanding of what the code is doing.
Yes, Martin is doing a great job as onboarding new new people to at beginning it's not even coding, it's like tidying data even without coding, and then we can see that coding helps a lot in doing the boring tasks and lowering the risk of error. And so it's very step by step. And yes, as you say, the human part of it and the enthusiasm make a lot in that, in adopting and new habits, new tools. Yes. So if we need an additional dose of enthusiasm at some point, maybe we will call you again.
That sounds great. That sounds great. Well, I will need to go now, but I really appreciate this. Thank you so much for the invitation, and good luck with the workshops. I can't wait to hear how they go. Please reach out and keep me up to date as possible on your end. That'd be really great.
We will.
That goes for everybody.
Well, thank you very much.
Thank you very much.
Okay, bye-bye.
Thanks all.
Thank you,
Bonne
Julia.
journée.
Merci.